In this video, I'm gonna go over some math reviews for pre-SAT and ACT, and so I'm gonna cover some math concepts. So students in 6th grade, 7th, 8th, or maybe high school student can watch this video to review their math concepts. Okay, so we're gonna start with the integers and then we go from there. So an integer is a whole number that can be positive, negative, or a zero. For example, let me write down first. I'm gonna start with the integer. So is a whole number, not a fraction, and that can be positive, negative, or zero. Okay, and example is, let's say 0, 5, negative 6. Let's say if I got 4010, negative 15. So these are the examples of integers. And the numbers that are not integer, so let me write those two. So not integer. For example, some fractions like, or mixed number 1/78, decimals 2.15, 10%, which can be written as 10 over 100 or 1 over 10. So these are the number, these are not integer. Okay, so integer is an whole number that can be positive, negative, or zero. Okay, so now let's move to the next uh, topic. So even numbers. So what are the even numbers? Okay, I'm gonna start with the very basic, even numbers. Even numbers are integers that are, or those numbers are divisible by 2. And for example, let me write 0, 2, 4, 6, 8, 10, 12, and in this side of number line, negative 2, negative 4, negative 6, and so on. Okay, so these numbers are even number. And how about odd numbers? So are integers that are not divisible by 2. Not divisible by 2. Let me write all the odd numbers here. Let's say 1, 3, 5, 7, 9, and so on. And this side, negative 1, negative 3, negative 5, negative 7, negative 9. So these are all the examples for odd numbers. Okay, so even numbers divisible by 2, odd numbers are not divisible by 2. And let's move to the next topic. So we're gonna write some rules for even and odd integers, when added, subtracted, or multiplied. So one rule, I'm gonna write it over here. So let's say you got an even number, either you add or subtract another even number, the result will be even. For example, let's say I got 6 plus 2, see, even plus even, and the result is 8, which is even. And now I got 6 minus 2, now I'm subtracting even out of even, gives me 4. So either when you add or subtract and both numbers are even, the result is even. Second rule, let's say one of the number is even, either you're adding or subtracting an odd number from this one, the result will be an odd number. So for example, you got 8, you're gonna add 3 into it. See, even plus odd gives me 11, so result is odd here. So let's say again even number 8, and I'm subtracting 3 out of it, which is odd, so result is odd again. Alright, so let's do number 3, third rule. Let's say I got odd number, So either I'm adding or subtracting an odd number, the result will be even. So both the number are odd, either you are adding them or subtracting them, the result you are getting is even. So 7 is an odd number, let's add another 7 to it, so the result is 14, which is an even number. Let's say 15 is an odd number and you subtract another odd, which is 7, the result will be 8, which is an even number. So that works. Let's go to another rule, number 4. So when even number multiplied by an even number, the result is even. Okay, so easy examples, 2 by 4, both are even. When you multiply, answer is 8. Okay, so let's write it down, the other one. So even number multiplied by an odd number, even number multiplied by an odd number always gives you even number. Okay, for example, 2 is an even number multiplied by odd, which is 7, gives me 14. And let's say I got 4 multiplied by 15, answer is 60, which is again an even number. Alright, let's write another rule, which is going to be odd number multiplied by an odd number, and the answer is odd. For example, let's say I got 5 is odd, 7 is odd, so 5 multiplied by 7 gives me 35, so both are odd number. And let's say 3 is odd multiplied by 5, 3 times 5 is 15, again it's odd number. So these rules or tricks helps you to solve problem faster if you memorize them, I will say. Okay, so use them. Let's move to the next page. So next thing I'm gonna go over is prime number. Okay, so what is a prime number, or what are prime numbers? So an integer that is greater than 1, that is only divisible by itself and 1, are called prime numbers. And examples are 2, 3, 7, 11, 13, 17, 19, and so on. Okay, so these are the number greater than 1, see 1 is not included, that is only divisible by itself and 1. For example, 7, you can't divide it by any other number unless you getting a decimal or fraction. We need a whole number, so 7 is not divisible by any number. So let's say only 1 gives me 7, or 7 is divisible by 7 gives me 1. All right, and let me see. So one interesting thing here is 2 is the only prime number that is even. Rest of the prime numbers, all of them are odd. Okay, and now this is a prime number. So what about the other numbers? Okay, so an integer that is greater than 1, that is not a prime number, is called composite number. So composite number is a multiplication of two numbers. Let's say 15 is a composite number, which can be written as 3 by 5. It can be divided by either 3 or 5 or 15 or 1. But prime numbers, they are only divisible by themselves or by 1. Okay, so 15 is a composite number. So fun fact is 1 is neither a prime number, neither a prime or a composite. Okay, the second fun fact will be 2 is only even prime number, is only even prime number. All right, so let's go to next page. So next thing is multiples. What are the multiples? okay, or a multiple. So multiple of a number is the product of that number and another number. Okay, for example, let me write down the multiple of a number is the product of that number and another number. So multiple of, for example, multiples of 3 are 3, 6, 9, 12, 15, and so on. So 3 times 1 is 3, 3 times 2 is 6. So multiple of a number is the product of that number and another number. So for example, 3 times 1, 3 times 2, 3 times 3. So multiple of a number is the product of that number, which is 3, and another number, which can be 1, 2, 3. Okay, so those are called the multiples of 3, like 3, 6, 9, 12 when you write a multiplication table. Okay, and the fun fact is all even integers are multiple of 2. Okay, let's write down other thing. So how about common multiples? So let's write down common multiples. What are common multiples? So a number that is multiple of 2 or more numbers. Okay, so which is a multiple of 2 or more number. So for example, let's say we got a number 6 and a 12. Find the common multiple of these two numbers. So how we gonna find that? So what I'm gonna do, I'm gonna write the multiplication table for 6. Okay, which is going to be 6, 12, then you can say 24, 18, 24, and so on. Okay, and then what we're gonna say, write for 12. So which is going to be 12, 24, 36, okay, and so on. So what are the common multiples of 6 and 12? It's going to be 12, 24, and 36. Like 12, 24, 36, and there might be more which are like common in 6 and 12. Okay, and then we're gonna find the least common multiple. Okay, so least common multiple. So out of those common multiple, which one is the least number? If we look carefully, 12 is the smallest common multiple in 6 and 12. So the least common multiple for 6 and 12 is 12. Alright, and that was multiples. Now factors. Next thing is factors. So a factor of a number is a number that divides evenly into that number. Okay, again, a factor of a number is a number that divides evenly into that number. Let's say I got number 6. So what are the factors of 6? 1 is a factor because 1 divides 6 evenly. How about 2? Yes, 2 divides 6 evenly. 3 divides 6 evenly, and 6 divides 6 evenly. So 1, 2, 3, and 6 are the factors of 6. Okay, now let's find how to say it, common factor. Same thing as we did common multiples. So common factors. A number that is a factor of 2 or more numbers is called common factors. So a number that is a factor of 2 or more numbers is a common factor. For example, let's say I got 4 and 2. So what are the common factors for 4 and 2? I think 2 can divide both of them, yes. and 4 can divide both of them too. So 2 and 4 are the common factors for 4 and 8. How about 8? No, because 8 can divide only 8 evenly but can't divide 4 evenly. So 8 is not a common factor for 4 and 2. So only 2 and 4 are the common factors. So next thing is prime factorization. So factor the number until all factors are prime. Okay, for example, let's say if I got 45, I need to factor it until all the numbers are prime. Okay, so we can use the tree method. 5 times 9 is 45 and 3 times 3 is 9. So 5 is a prime number, 3 is a prime number, this 3 is a prime number. So 45 is basically equal to 3 times 3 times 5. So these are the prime factors of 45. Let's write one more. Let's say I got 100. So 100 is basically 2 times 50, and 50 can be written as 2 times 25, and 25 can be written as 5 times 5. So 100 is basically 2 times 2 times 5 times 5, and these are all prime numbers. So these are the prime factors for 100. Okay. Another thing is greatest common factor. Greatest common factor. Okay. So the common factor of 2 or more numbers that has the greatest value, or that has a greater value. So how we can find it? Let's say I got 3 numbers over here. I got 25, I got 30, and I got 50. So I need to find the greatest common factor for these 3 numbers. Let's do it. So what we need to do, we need to write the factors for 25 first of all, which is going to be 1, 5, 25. Okay. How about 30? What are the factors of 30? 1, 2 times 50 is 30. Then comes 3 times 10. Then comes 5, 6, 10, 15, and 30. Let's write the factors for 50. So we got 1, 2 times 25 is 50, 5 times 10 is 50. We got 25 times 2 is 50, and 50 times 1 is 50. So the greatest common factor is, let's look for the common factor in all of them. 5, 5, and 5. So that's the only common factor these all 3 numbers got. Okay, so the answer is 5. So now we can use the prime factorization to find, or we can use the prime factors to find greatest common factor also. Greatest common factor or least common factor. So how we can do that? So let me write down using prime factors. Find greatest common factor or least common multiple. Okay, so let's start with the greatest common factor. Let's say I got 3 numbers, 8, 12, and 20. Okay, so let's write down the prime factors for 8. Remember, we're going to use the tree. 2 times 4 is 8, and 2 times 2 is 4. So 8 can be written as 2 times 2 times 2. Okay, then same thing for 12. 12 can be written as 2 times 6 and 2 times 3. So 2 times 2 is 4 times 3 is 12, and third number is 20. Let's write the tree here. 2 times 10 and 2 times 5. So that gives me 2 times 2 times 5. So these are the prime factors for 8, 12 and 20. And now we're going to find the common factors here. Let's start with the 1 and 2. Is there a 1 and 2 in all of them? Yes, yes, yes. So 2 is one of the common factor. Let's see if there's another 2 that is common in all of them. 2 is here, 2 is here, 2 is here. Yes, 2 is in all of them. How about the third 2? Here, yes, but here, no, here, no. How about 3 in all of them? No. How about 5? No. So 2 times 2, which gives me 4. So 4 is the greatest common factor of 8, 12 and 20. So that's the answer. The greatest common factor for 8, 12 and 20. Okay. Now let's find LCM. So we're gonna find LCM, least common multiple, using prime factor of 46. I got 69 and I got 150. Okay, so let's write prime factors of 46 first, which is just 2 and 23. 23 is a prime number. So prime factors for 46 are going to be 2 times 23. Okay, then we got 69, which is going to be 3 times 23. So 69's prime factorization is 3 times 23. How about 115? It's going to be 5 times 23. 115 is going to be 5 times 23. So in case of least common multiple, we need to find all the multiples here which are common. Okay, sorry, we need to include all the multiples that are here. So 2 is here, so 2 is one multiple. Okay, then we got 3, then we got 5, and then we got 23. 23 is 3 times, but we're going to multiply just one time here. Okay, so when you multiply all of them, this gives me 690. So 690 is a least common multiple of 46, 69, 115. That tells me if you read a multiplication table for 46, you will find 690. So does in this one, so does in this one, and that will be the least number that is a common multiple of these three numbers. Okay, so that was the least common multiple. Now let's move to another topic that is, student learn in 5th grade, 6th grade, 7th, and use it until high school or college. So that is fractions. Okay, so fractions represent part of a whole. So it represents basically a part of a whole. Okay, so let's say I got a fraction which is 3 over 5, and here 3 is the numerator and 5 is called denominator. So 3 over 5 means 3 parts of whole, which is made of 5 parts. Okay, so let me make 5 equal parts over here. So 1, 2, 3, 4 and 5. Assume they are equal. They are not, but assume they are equal. Okay, so we got a whole that is made of 5 parts of 1, 2, 3, 4 and 5, and we are looking into only 3 parts of it. So if I shade 3 boxes here. So that's what this fraction represents. 3 parts of whole that is made up of 5. So 3/5. Somebody asks you how much of this whole is shaded, you're gonna say 3/5 is shaded. Okay. And now in fractions that has numerator greater than denominator, it's called improper fraction. Improper fraction. So that's where numerator is greater than denominator. For example, if I got 10/3, so that is a improper fraction. And it can be improper fraction can be written as mixed number. It can be written as mixed number. So mixed number is basically a sum of a whole number part and a fraction part. So it has a whole number part and a fraction part. I'm gonna show you what it means. So let's say 10, I'm dividing it by 3. So 3 goes to 3, gives me 9. I left with the 1 remainder. So we move in this direction, you know. So it can be written as 3/1/3. So that is a mixed number. Okay, and how you can get improper fraction out of this? So these two numbers, we multiply them and then we add this number in the numerator. So 3 times 3 is 9 plus 1 is 10. So 10/3. So this is a mixed number. So this is basically 3 plus 1/3. So 3 is a whole part and 1/3 is a fraction part. That's why we call it mixed number. It has a whole and fraction. All right, so let's go over some rules for fractions operation, like how to add, subtract, multiply, or divide fraction. I have made another video on that too. If you guys go to my channel, and there's a whole video on our operations for fractions, like adding fraction, subtracting fraction, or multiplying and dividing. So let's go over adding. So if we are adding fraction, let's say I got 1/2 and I'm adding another 1/2. So in this case, look into the denominator. Denominator is the same. In that case, it is just 1 plus 1/2 gives me 2/2 gives me 1. So they both have a common denominator. But in the case, let's say I got 1/2 and then I got 1/3. So both fractions have different denominator. So in this case, we need to find the lowest common denominator. There is another way to do it too, but I'm going to show you this one first. So first of all, we need to find the lowest common denominator. How you can find it? So let's write down the multiples of 2, which is going to be 2. Start with the 1, 2, 6, 4, 6, 8, and so on. Then we got 3. So 1, not a factor, multiples. So 3, 6, 9, 12, 15. And now you notice 12 is common in both of them, least common multiple. Okay, so what we need to do, we're gonna change the denominator to 12 in both the fractions. Okay, so how you can make this 2 as a 12? If I multiply this 2 by 6, right, but I need to multiply the denominator by 6 too. How we can make denominator 12 here? If I multiply this 3 by 4, but I need to multiply it in the numerator too. So what we got, I got 6/12 plus 4/12. That gives me 6 plus 4 is 6 plus 4 over 12, which is going to be 10/12. That's how you can add fractions with different denominator. Okay, or there is a one more way to do it too, or if I reduce it, this will give me 5/6. So another way is, that's the shortcut, if you don't want to do this to find common denominator, you just cross multiply them, and denominator will be the multiplication of these two denominator. So 2 times 3 is 6, and 3 times 1 is 3, and 2 times 1 is 2. This gives me 3 plus 2 is 5, divided by 6. See, we got the same answer. So that is one of the shortcut. If you don't like to find the common denominator, you can do it this way too. All right. And now let's say same thing with the subtraction, same rule. And how about multiplication? So let's say you got 1/2 multiplied 1/3. So what we need to do, multiply numerator with the numerator. So 1 multiplied by 1 gives me 1. And multiply denominator with the denominator. So 2 multiplied by 3 gives me 6. Okay, so that's how you multiply. How about division? I got 1/2 divided by 1/3. So what we need to do, write this first fraction 1/2 and change the division sign into multiplication sign, and reverse this number over here, right? The reciprocal of this number. So 1/3 can be written as 3/1. So this gives me 3 times 1 is 3 divided by 2. Okay, which is basically improper fraction. You can write it in mixed number format. Okay, so when you're multiplying, multiply numerator with the numerator, denominator with the denominator. When you're dividing, write the first fraction as it is, change the division sign to multiplication sign, and write the reciprocal of the second fraction. Okay, and then do the multiplication. So that will be the division of those two fractions. And another interesting thing you can learn, how to compare fractions. So let's say they give you 1/3 and then they give you 1/6, and they ask you which fraction is greater, and you are confused. So what you need to do, change the denominator. Okay, make denominator equal in both the fractions. For example, here it's 6, this is 3. I can make this denominator 6 if I multiply it by 2, and I'm gonna multiply by 2 over here too. So what I got here, 2/6, and I got 1/6 over here. And you can tell, so 2 out of 6, okay, or 1 out of 6, which one is bigger? Obviously 2 out of 6 is bigger compared to 1 out of 6. Next topic I'm gonna go over, that's where we're gonna learn decimal, percent, and fractions. That's we just learned, but we're gonna learn how to convert them from one format to the other. Okay, but before we let's do that one. Yes, let me write what is the percent first thing here. Let's learn that. So if I wrote 50%, so that means 50 cent means 100, so 50 per cent, 100, like 50 out of 100. So 50 parts out of 100, okay, which is basically 1/2, right? If you reduce this fraction, and when you do the division, this gives you 0.5. You see, this is a percent here. You can write it as a fraction, and you can write it as a decimal. So 3 different forms. Okay, so let's do a couple of examples and see what we can learn from here. How about somebody gave me 45%, so I'm gonna write it percent here, make another box. I'm gonna write it fraction. Third one I'm gonna say decimal. So somebody gave you 45 with a percent sign. They said change that into a fraction. So whenever they give you a percent and you like to write it in a fraction format, divide it by 100. That's it. Whenever there's a percent sign, write the number, divide it by 100. So that's your fraction. And 45 divided by 100 is 0.45. So that's your decimal. Now let's say if I got 145%, so it's going to be 145 divided by 100, and it's going to be 1.45. So fraction here, decimal here, and percent over here. Okay, so when we are changing, let's say, percent to a fraction, okay, see what did we do? We divide by 100. So divide by 100. Now if we are doing the other way around, like we are changing a fraction to a percent. Okay, so when you're changing a fraction to a percent, we're gonna do the opposite of it. Here we are dividing, here we're gonna multiply by 100. Okay, multiply by 100. Now let's say decimal here too. So example, I'm gonna write the example over here. So they gave you a fraction 3/4, and I want to change that fraction into a percent. I'm gonna multiply it by 100. So that gives me 25 times 3, 75%. You see, when it was percent, we divided by 100 to get fraction. Now it's a fraction, we want to get percent, we're gonna multiply by 100. So we're gonna do opposite of it, 75. And let's say we got 0.75, so decimal, I want to change that into a percent. Again, multiply by 100, that gives me 75%. So there are few problems on the percent you will see during the exam or test. I'm gonna write just the basic just to clear the concept. Okay, so let's say one of them, the easy one, I'll say, what is the 50% of 40? Okay, so we're gonna find the 50% of 40. So 50% means 50 over 100. Of in math means multiplication sign 40. Okay, so that gives me 50 times 40 over 100. So 200 over 100. So answer is, 2000 over 100. So answer is going to be 20. So 50% of 40 is just 20. Okay, that's one kind of problem. So other kind of problem can be, let's say 5 is what percent of 20? 5 is what percent of 20? So let me write it in a mathematical format. 5 is, let's say, x percent of 20, right? So we convert that into a math formula or a math equation. Okay, they said 5 is what percent of 20? Okay, so let's change it again. So 5 is, x percent means x over 100, of means multiplication, and 20, right? So 20 times 1 is 20, and 20 times 5 is 100. So that gives me 5 is equal to x over 5, multiply both sides by 5. So this 5 will cancel this. Therefore, I got x is equal to 25. 25% to be specific. So 5 is 25% of 20. Okay, so that's what it is. So the next topic I'm gonna go over is, some students get confused, but it's okay. Just review it and revise it, solve some problem, you will be good to go. It's going to be absolute value. Okay, absolute value. What is the absolute value of a number? So the absolute value, let's say absolute value of a number let's say x, and it is denoted by x in these two vertical bar, is the distance of this x, excuse me, from 0 on a number line. So let's say I got number line over here, okay, 0, 1, 2, 3, 4, and so on. Here is a x. Same thing on a number line. 1, 2, 3, 4. I wrote it 5, 1, 2, 3, 4, and negative x. Okay. So on number line, the number in this direction are decreasing. In this direction, they are increasing. Okay. So the distance from 0 of this x, okay, here, distance is same from the 0 and is never be negative. So absolute value of x is going to be x, always positive. Okay, let's say if I got absolute value, for example, negative 4, right? It's going to be 4. If this number is a negative 4 here, this one, and this is 4 over here, the distance from the 0 for these 2 points is going to stay 4, and that's what absolute value is. So absolute value of x, denoted by this vertical bar, is the distance of the x from the 0 on the number line. Okay, so here if I wrote positive 4, it's going to be 4. So this is basically the distance between 0 and this negative 4. The same thing for here, distance of this 4 from the 0. Alright, and there are some properties of absolute value that are really helpful to solve some problems. So one of them is going to be, let me write properties of absolute value. Let's say if I got x is equal to a and a is greater than 0, then x is going to be either a or minus a, like we did the previous example. Doesn't matter. Okay, either it's positive a, the absolute value is again a, either it's a negative a, it's still gonna give me answer a. The second thing, if absolute value of x is less than a, okay, and a is greater than 0, then you can write it in this format also. So x is going to be either less than a or it's going to be greater than negative a. Let me write one example here to understand it. Okay, so let's make a number line here. So I got 0, then I got 1, 2, 3, negative 1, negative 2, negative 3. Okay, so let's say a is equal to 2, right? So a is greater than 0. I said a is 2. All right, so that means absolute value of x is going to be less than 2. So what value of x we're going to use from here? If you look at this number line, see the numbers in this direction are increasing, in this direction they are decreasing. If we keep going in this way, it's decreasing. If we keep going in this way, it's increasing. Okay, now look at it. So if x is here, this is my 2. If I use this 2 number, okay, doesn't work because 2 is not going to be less than 2. So I need to pick a number that is going to be less than this 2. So this 2 is my far edge. I can't use this number. So that's why it is going to be less than 2. Then this inequality will hold. Otherwise, it will not work. Okay. So this is not going to work. if we are using 2, the number is going to be less than this 2. See, so x is going to be less than 2. How about on this side? Okay, so if I choose any number that is going to be greater than this negative 2, so number greater than this negative 2 is going to be negative 1 here, right? Okay, so if I plug in negative 1 here, okay, so you will see I wrote 2 here, absolute value is 1. You see, 1 is less than 2, it works. But if I choose any number less than negative 2, so we're gonna move to, let's say, negative 3 over here. So if I plug negative 3 here, right, so negative 3, absolute value of negative 3 is going to be 3. Is it less than 2? No, so that is wrong. So we need to choose a number between, let me use other color, between this negative 2 and this positive 2. So they are going to be less than this 2 and greater than this negative 2. So this is the solution here. When a is greater than 0. Okay. So you guys can just remember this rule and write the equation or expression like this. Okay. So let's go to the next one. You will see the next one similar to that one, but third one is if absolute value of x is greater than a and a is greater than 0. The previous one, this was less than a, but here it's greater than a, right? Then the value of x is going to be either greater than a or it's going to be less than negative a. If you ever forget the rule, you know how you can remember it? Whatever they gave you, like here, less than a, use one of them. X is less than a, opposite sign and with a negative in front of it. Same thing here. X is greater than a, so x is greater than a, or x is, use the opposite sign, less than, use the opposite sign here, minus a. So that's the solution. Okay, let's try to find it on a number line here. 0, I got 1 here, 2, 3, and so on in this direction. Negative 1, negative 2, negative 3. So numbers are decreasing in this direction and increasing in this direction. So let's say if I got a is equal to 2 again, right? So that means absolute value of x is greater than 2. So what is the value of x here? They said according to the rule it's going to be x is greater than 2 or x is going to be less than minus 2. Okay, let's look at the number line. So x is greater than 2, so 2 is here. Any number that is greater than 2 is the solution, and any number which is less than negative 2, you know the numbers decrease in this direction, so any number less than negative 2 is the solution, and we can try that. Let's try 3. If I plug in x is equal to 3 here, the absolute value of 3 is greater than 2, and that's right. That's why if we plug in 1 here, if I plug in 1 over here, so that gives me 1 greater than 2, 1 greater than 2. Is it true? No, it's not. So 1 is not the solution. So number need to be greater than 2, the solution of this expression here, or inequality here. Or it's going to be less than negative 2. Any number that is left of this negative 2 will work. Again, let's try negative 3. So negative 3, because the absolute value of negative 3 is 3, which is greater than 2. So that works. So solution for this equation is going to be x greater than 2 or x is less than -2, and on the number line you will represent the solution that will look like this. Okay, and this is going to be a hole here, not a solid dot. Means this 2 is not included. If it's an equal sign, that means this 2 is included. So it's going to be greater than 2, not 2 exactly. All right, another property in absolute value is, so let's say I wrote x minus 5, the absolute value of x minus 5. This is going to be equal to 5 minus x. Same, we can try it. Let's say if x is equal to 7, if I plug in x is equal to 7 over here, I got 7 minus 5. This is the left hand side of our equation. Okay, it's going to be absolute value 2, which is 2. How about right hand side, which is 5, and x is minus 7 here. It's going to be minus 2, and it's going to be 2. That tells me left hand side is equal to right hand side. So it does not matter where you put these numbers. Wonderful, thank you. So let's do some examples on absolute values. So one of them is, what is the absolute value for -8? Remember, always positive. So it's going to be 8. How about absolute value of 15? Just 15, right? How about absolute value for, let's say I got -6, 3 minus 8 here. Okay, so -6, when we solve it, -5, -6, and absolute value of -5 is going to be 5. So answer is -30. All right, so let's write another one. Absolute value of 6 multiplied by -2 inside the mod. Okay, it's going to be 6 times -2 is going to be, -12, which is going to be 12. How about a negative sign inside a -10? So negative, absolute value of -10 is going to be +10. There you go. And there is one interesting thing I learned, like how do we convert the general interval into an expression using the absolute value? Okay, so we got, for example, I got 40 less than or equal to x less than or equal to 80. Okay, so we're gonna change that into an expression. So there are 3 steps. So step number 1 is find the midpoint of 40 and, that's 60. Find the midpoint of these two numbers, which is going to be 40 plus 60 divided by 2 is going to be 100 divided by 2 gives me 50. Second step is find the distance from the midpoint to these two endpoints. Okay, so one of them is going to be 60 minus this 50 from the midpoint is going to be 10. How about another one? So 50 minus 40 going to be 10. So distance of a midpoint from these 2 points is going to be 10. And we're going to write the absolute expression now here. The rule is substitute the midpoint and the distance of midpoint from the endpoint in this equation, which is x minus midpoint, and whatever inequality is there, in our case less than or equal to distance, so which can be written as x minus 50 less than or equal to distance is 10. So that's how you can write this interval in this expression using absolute value. So So here there is no absolute value, but here there is the absolute value. So these are the solutions to this absolute value expression or inequality. Okay? You can use this to solve some problems. Okay. Next topic is going to be like how to add, subtract, or multiply or divide integers, so operations for integers. I have another video on that, just whole video. That's where I explain how we can add, subtract, or multiply or divide the integers. So first of all, let's say I'm adding integers. There are some tricks we can use. Okay, so I got 3 plus 8. 3 plus 8 is just 11. Then I got 3 plus minus 8. What will be the answer? If I go to the number line here, okay, so I got 1, 2, 3, 4, 5, let's say 0, 1, 2, 3, and this side I got -1, -2, -3, -4, -5, -6, -7. Okay, so I'm taking out 8 from the 3. So 3 is here. I'm gonna take out 8. So I need to move. That means the end result. You got a number and you are taking out something of it. That means the end result going to be smaller compared to the original or the given number. Okay, so if it's going to be smaller, in this direction numbers are going bigger. In this direction numbers are going smaller. So we're going to take out 8 and we're going to move in this direction. Okay, how many times? 8 times. 1, 2, 3, 4, 5, 6, 7, 8, which is -5. So answer is going to be -5. Or there's another way or a trick I always use. So 3, whenever positive and negative are in multiplication here, it changes to negative, and I wrote 8. Okay, so this is a basically subtraction. You subtract 3 out of 8, you got 5. Now we need to figure out what sign. Is it a +5 or a -5? So look into these two numbers. Which number is bigger? 8 looks bigger, right, compared to 3. What is the sign in front of 8? It's a negative. So whatever is the sign in front of bigger number, we're gonna use that sign. Okay, this is basically, I did subtraction of integer, but you can write it as addition of integers. Okay, now subtracting, same thing as I said. I got -3 and I'm subtracting -4 out of it. Let me see subtraction over here. Let's look into the number line again. So I got 0, got 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So -1, -2, -3, -4, -5, -6, -7, -8, -9. So I got -3 here. So number is -3, which is here. And you are taking out 4 from this. That means the end number is going to be smaller than the beginning number, the original number, which is -3. So if it's going to be smaller, we need to move in this direction, because in this direction on number line numbers are going smaller. So we are taking out 4 from this. So 1, 2, 3, 4. So what is the final answer? -7. Okay, that's how you can subtract. Let's do multiplication. If I got 5 multiplied by -3, answer is going to be -15. If I got -5 multiplied by -3, when there are both signs, negative multiplied by negative gives you positive. So answer is going to be +15. I'm gonna write division over here. Same rule. If I got -15 divided by 3, answer is -5. How about +50 divided by 3? Again negative 5. How about negative 15 divided by negative 3? Negative will cancel the negative. Answer is going to be positive 5. So that's how you can add, subtract, or multiply the integer. Again, as I said, I have a whole video on this in detail if you like to watch on my channel. So next concept I'm going to go over is square and square roots. So we got squares and square root. Okay. So any number raised to the power of 2 is called squared. Let's say I got 1. If I put 2 as a power, so that is 1 square. If I wrote 2, put 2 is as a power, is square, and square of 2 is going to be 4. Again, any number raised to the power 2 is squared. And perfect square, the perfect squares are the squares of whole numbers, like as I wrote 1, 2, 3. This is a perfect square. 9. So 3 is a whole number. How about 4 square? 16. Okay. And then comes square root. So square root of a number n, let's say, I'm going to write it down here. Square root of a number n is a number that when multiplied by itself, equals n. Let's do an example. So I got 1 square is basically 1, and square root of 1 is going to be 1. Let me write another one, then I'll go over it. 2 square is equal to 4, that means square root of 4 is going to be 2. So square root of a number, so square root of any number n, let's say 4 here. So square root of 4 is a number, this number that when multiplied by itself equals to 4. See, the square root of 4 is 2, because when 2 multiplied by itself, 2 gives you 4 here. How about 9? Square root of 9. Square root of a 9 is a number that when multiplied by itself gives you 9, which is going to be 3. If 3 multiplied by 3 gives you 9. So square root of a 9 is 3. Okay. And basically, like when you go to higher, like 7th, 8th grade, teacher like to see plus or minus here. Plus or minus, plus or minus. You know why? Because 2 times 2 gives you 4, and negative 2 times negative 2 also gives you positive 4. Same thing here. 3 is the square root of 9. And negative 3 times negative 3 is also positive 9. So negative 3 is also a square root of 9. So answer is positive or negative. Alright. So that was square and square roots. So next thing we're going to work on exponents. Exponents. So for example, if I have to write 100, 100 can be written as product of 10 into 10. Okay, and can also be written by using exponent. We're gonna 10 raised to power 2. So this 10 is called base and 2 is called its exponent. Okay, so this basically shows how many times a number, this which is called the base, is used as a factor. See here, 100, 10 times 10. So 10 is used 2 times as a factor of 100. So that's why it's 10 raised to power 2. So which shows how many times a number called the base is used as a factor. How about 1000? So 1000 can be written as 10 times 10 times 10, which is equal to 10 raised to power 3. So that's the exponent. How about 10,000? So 10 times 10 times 10 times 10. So base, which is 10, raised to power how many factors? 1, 2, 3, and 4. So those are the exponent. So this form over here, this form is called standard form of the number. And this form here is called the exponent form of the number. Let's say 8. 8 can be written as 2 times 2 times 2. So 8 is a standard form, and the exponent form is going to be 2 raised to power 3. Okay. So those are the exponents. So now we're going to learn some rules for exponents. So I'm going to say exponent rules. Okay, let's write down one of them. Let's say you got 4 raised to power 3 and 6 raised to power 2, and you have to add them. So what are we going to do? So adding the exponents. So this is the rule for addition or adding. What are you going to do here? So when you add or subtract, same rule, even if you're subtracting. If you're adding or subtracting a number with exponent, convert each number into their standard form and then perform the operation. So first of all, we're going to write them in their standard form. So 4 raised to power 3 is 4 times 4 times 4 plus 6 raised to power 6 is 6 times 6. So this is going to be 64. This is going to be 36. So this is a standard form for 4 raised to power 3, and this is the standard form for 6 raised to power 2, and this is going to be 100. Okay, and that can be written as 10 raised to power 2. So when you add them, this is basically equal to 10 raised to power 2. And same thing with the subtraction. You have to write them in standard form and solve it. Let's say 6 square minus 4 cubed. So, oh, sorry, that'll be negative, but 4 cube minus 6 square, I'm subtracting them. So 64 minus 36, it's going to be 28. That's the answer here. Okay. How about when you're multiplying? When you're multiplying, let's say you got 3 square into 3 cube. So when you're multiplying exponent and they have the same base, see, both have 3 as a base and different exponent, the rule says you just add the exponents. So 2 plus 3, so this is going to be 3 raised to power 5. That's your answer. So I'm going to write those rules here. There are quite a few of them, so you understand, you know. How about dividing? So as I did the multiplication, so let's say I got 3 raised to power 4, you're dividing it by 3 raised to power 2. Again, the base is same, so you write the base, common base. In division, you subtract them, 4 minus 2. So this is going to be 3 raised to power 2. If it's a multiplication, you add them, remember. So 3 raised to power 4 plus 2, so 3 raised to power 6. In division, you subtract them. Okay, so let me write some more rules. So first of them is 0 exponent. 0 exponent. So 0 exponent, you got a number raised to power 0, so answer is always 1. Any number, 2 raised to power 0, 3 raised to power 0, they all equal to 1. Any number raised to power 0 is always 1. So second rule is negative exponent. Okay, so you got a raised to power negative n. So what you need to do, bring that in the denominator and change the negative to positive exponent. For example, 2 raised to power negative 1, it can be written as 1 over 2 raised to power positive 1. Okay. Third rule, product of power. Again, I have another video on this too. Just the rules of exponents. So product of power, I got a fraction a raised to power m, and then I got I got exponent a raised to power m, a raised to power n. That's what we learned here. Same base, you add the power, m plus n. This is the example you can use. Okay. Then comes fourth rule, which is quotient of power. Quotient of powers, which is a raised to power m divided by a raised to power n. So this is the division rule here. What you do, a raised to power m minus n, keep the base same and subtract the powers. That's what we did over here in this example. Okay. Next one is power of products. Let me write it down. Power of products. So you got a multiplied by b raised to power n. Okay, so power of product of two numbers. It's going to be a raised to power n into b raised to power n. For example, you got 3 times 4 raised to power n, or let's say 2 square. It's going to be 3 square into 4 square. Okay. Fifth rule is going to be power of power. Okay, you got a raised to power m, and this whole thing is raised to power n. So what you need to do, multiply these two powers, m multiplied by n. So example is, if I got, let's say, 2 raised to power 3 raised to power 2. So this is going to be 2 raised to power 3 multiplied by 2, 2 raised to power 6. So this one number 6 basically. Let's write one more. So this is the one you might be using in solving radicals. Okay, so if I got a raised to power m over n, so this exponent is in a fraction format, so it can be written as a raised to power 1 over n raised to power m. In that case, it's written as nth root of a raised to power m, or that's the same, a raised to power m over n. This time I'm gonna keep the m inside, I'm gonna take one n outside, same thing. So here it's going to be a raised to power m and the nth root on it. Okay. So they both are same. If you find the final answer, if they give you any exponent in this format, you use both method, the answer will be same. Unless there are variables, then it looks a little different. Alright, so those are the rules for exponents, very useful. Okay, next thing I'm gonna go over is radicals. Okay, radicals. So this is basically exponents in reverse, and radical symbol is this symbol. We call it root, square root, nth root, cube root. So this symbol is basically the symbol of radical. Okay, in numbers, nth root is the non-negative number which, when multiplied by itself n times, gives you the original number. So like we did in square root, and for example, cube root of 125 3. So we need to multiply. So what will be the cube root of this nth root? So we need a number that need to be multiplied 3 times with itself to give me 125, which is going to be 5 times 5 times 5. So 5 is the cube root of 125. That's what they're saying. In numbers, nth root in our case, its cube root, is the non-negative number which when multiplied by itself n times, and here if it's a cube root, it will be multiplied 3 times. That gives you the original number. So 5 times 5 times 5 times gives me 125. So cube root of 125 is 5. I hope that makes sense. Okay, one more time. A numbers, let me write it down. In numbers, nth root is the non-negative number which when multiplied by itself. How many times? N times. Multiply with itself n times and gives the original number. And that's what I'm saying here. Let's say third root of 125. So we need a number that we multiply by 3 times because it's the third root. So if it's the nth root, we need to multiply n times. This is in general. So this is a real example. Okay. So 5 is going to be the cube root of 125. Some examples you can use, like square root of x into square root of y can be written as you combine both, put inside the square root. And then comes square root of x over square root of y. You can write in one square root, x over y. Okay. So the example in this case is square root of 4 times square root of 9 going to be square root of 36, which is going to be 6. And if we do it separately, square root of 4 is 2, square root of 9 is 3. So 3 times 2 is 6. Answer is again same. And then we do, let's say, square root of 100 divided by square root of 25, which is going to be square root of 100 over 25. So 20 times 4 is 100, so square root of 4, which is going to be 2. Let's find out. Square root of 100 is 10, square root of 25 is 5. 5 times 1, 5 times 2 is 10. So we still get answer equal to 2. Okay. And let me write one more example or two more here. Little different. So if I got square root of 25 times square root of 3, which can be written as 25 times 3. So what we can do, we can take this square root factor out. Square root of 25 is 5. Inside we left with square root of 3, right? And if we got, let's say, x cube dot y cube, which can be written as x square y square into x into y. And the square root of x square into y square is basically x y. And inside we left with this square root of x y. Make sense? Okay, so let's do one more. So I got 36 x raised to power 4 raised to power 1/2. Okay, so this is basically square root of 36 into x raised to power 4. Square root of 36 is 6. Square root of x raised to power 4 is going to be x squared. You know why? So x4 1/2. That's a square root, which is basically x4. And this can be written as x raised to power 4 times 1/2. Remember, power of a power rule, multiply the power. 2 times 1 is 2, 2 times 2 is 4. So this is going to be x squared. That's why I wrote square root of x raised to power 4 is x squared. And you know square root of 36 is just 6. Next topic is really important. You'll see a lot of problems on this too. So this is for ratios and rates, and you also see proportions. Okay, so let's go over it. First of all, I need to see the difference between ratios and rates. Okay, ratios, I'm gonna write ratios here, rates there. Okay, so ratios represent the relationship between two quantities that have same unit of measure. Same units of measure. Okay, so ratios represent the relationship of two quantities that have the same unit of measure, whereas rate represent the relationship of two quantities that have different units of measure. I'm gonna write the example too. So in ratio, when two quantities are compared by dividing one quantity by another, that comparison is called the ratio. It can be written as, let's say, 2/3 and 2/3 and 2:3. So when two quantities are compared by dividing one quantity by another, this comparison is called ratio. Okay, and let me give you an example here. So I got a field with field's length is 30 meter and its width is going to be 10 meter. So the ratio of length to the width, so ratio of length to the width is 30/10. It's going to be 3/1 or 3:1. Sorry. 3:1. How about rate? In rate, again, the unit of measures are different. So for example, a car is traveling a distance of 50 miles and it traveled this distance in 2 hours. So in this case, rate is going to be distance over time. See, they both have different unit. Distance is in miles, 50 miles, and time is in hours, 2 hours. That's why we call it rate. Okay, so going to be 25 miles per hour. So that is your rate. All right. Now let's say there are 50 how to say it? There are 50 apples in 5 baskets. Find the rate. That means 10 apples per basket. So that is a rate. These are apple, this is basket, that's different. Okay, or in a class there are 14 students and there are 70 pencils. Find the rate. So 70 pencils, 14 students, that gives me 5 pencils per student. So that is a rate again. Okay, because 14 times 1 is 14 times 5 is 70. And let's take another example of ratio. So let's say in school, in a class has 12 girls and 15 boys. So what is the ratio of girls to boys? So ratio of girls 12 to boys 15, 12 over 15. So same unit, so number. Okay, so that's the difference between ratio and rates. Okay. Another thing you will see, proportions. So there will be problems on proportions. So first of all, again, this video is about the review of concept, not solving many problems. So we are just reviewing, we are just brushing up our basics here. Okay, proportions. So proportion is an equation of two ratios. So there, with the help of proportion, you are comparing two ratios. Okay, and whenever you are setting up a proportion, keep same types of value in the numerator and same types of value in the denominator. Okay, let's say I got 70 pencils for 14 students. Okay, then question is, how many pencils for 10 students? Alright, so we're going to use the proportions. We're going to compare the ratios here. So 70 pencils to 14 students. So rate. Okay, so we are comparing the values over here, and they said keep the same type of value in the numerator. So if I wrote 70 pencils here, how many pencils we don't know, so I'm gonna say X pencils in the numerator. And student I wrote in the bottom, so here we got 10 students. I'm gonna write that in the bottom here. Okay, and now what we need to do, just cross multiplication. 10 times 70 is 700, and 14 times x is 14x. Divide both hand side by 14. Cancel out. So this is 5, 70 and 0, 50. So x is going to be 50. If we need 70 pencils for 14 students, then we need 50 pencils for 10 students. That's how you can solve problems using proportions. So basically you are comparing two ratios or two rates. Next topic is scientific notations. Okay, scientific notation. You need to know that before you start preparing for SAT or ACT. So scientific notations, there are two types. One of them is with the positive powers of 10. I'm going to write it down, positive powers of 10. So number written in scientific notation is expressed as a number between 1 and a 10 and multiplied by a power of 10. Okay, for example, let's say I got 15,000. I want to write it down in scientific notation. So write in scientific notation, so 15,000. So I'm gonna follow some steps. So number one step is place the decimal point to get the number between 1 and 10. So place the decimal point to get a number between 1 and 10. Okay, so I'm gonna put a decimal here, right? So 1.5000. So now this becomes a number between 1 and a 10, 1.5, right? Second step is count the number of places to the right of a decimal point. Let me write it down. Very important. Count the number, count the number of places to the right of the decimal point. Okay, let's count. So 1, 2, 3, 4 places. Okay. Now in third case, the second part of the number is the power of 10. So it's this 15,000 is going to be written as 1.5 and 10 raised to power. How many places we count? 1, 2, 3, 4. 10 raised to power 4. Okay. So basically, as I said, the scientific notation, the number, so the number written in scientific notation is expressed as a number between 1 and a 10 and multiply by a power of a 10. Okay, so first step is place the decimal point to get a number between 1 and 10. So we place decimal here, it becomes 1.5, which is a number between 1 and 10. And then we're going to count the number of places right of a decimal point. So 1, 2, 3, 4. And then we're going to write our scientific notation here. Let me do another example. So let's say I got 325000. Write it in a scientific notation. So first step is write this, move the decimal point, so that number will be between 1 and 10. So 3.25 is between 1 and 10. 0, 0, 0. Now count the decimal places here. Sorry, number of places to the right of decimal. So 1, 2, 3, 4, 5. That means 3.25, number between 1 and 10, multiply by 10 raised to power how many places? 1, 2, 3, 4, 5. 10 raised to power 5. So that's how you can write a number from standard form to scientific notation. So this is the case when the power, when the positive power of the 10, you see 10 raised to power positive numbers. How about when we have negative powers? Okay, so I'm gonna write negative powers of 10. So that we use whenever we are writing a scientific notation for a number that is less than 1. So if a number is less than 1, let's start with the example. So let's say I got 0.0053. Okay, so step 1 is move the decimal point to the right to produce a number from 1 to 10. Let me write it down. Move the decimal point to the right to produce a number between 1 and 10. Right? So I'm gonna move the decimal here. So if I put decimal over here, it will be between 1 and 10. So it's basically 0, 0, 0, 5.3. So second step is now count how many places the decimal point in the original number was moved. Okay, so how many places it moved? It moved from here 1, 2, 3. So it moved 3 places. So count how many places the decimal point in original number was moved. So decimal point moved 3 places to the right. And third step is, since original number is less than 1, the exponent is going to be negative. So our answer is going to be 5.3 multiplied by 10 raised to power, how many places it move? 3. But number is less than 1, so I'm gonna make it negative exponent. So that's how you can write the exponent when number is less than 1. Let's do one more example here. So if I got 0.725, okay, so move the decimal to make it between 1 and 10. So we're going to move it from here, it will move here, becomes 0.725. Remember, do not move it here, then it becomes 72.5, which is not between 1 and 10. So we're going to move it only 1 here, 7.25. So decimal point is moved by 1 place. So answer is going to be 7.25. 10 raised to power 1, it moved by 1 place, but with a negative exponent because this number is less than 1. I hope you understand this, guys. Solve a couple of examples, then you guys will be good to go. Other concept I'm going to do is, and you will see some problems on that too, arithmetic sequence. Arithmetic sequence. Okay, so in arithmetic sequence, so it's a sequence of numbers such that the difference of any two successive number of a sequence is constant. Let's say I got 1, 3, 5, 7, 9, and so on. So it says the difference of any two successive number of a sequence is constant. Let's say the difference between 1 and 3, it's 2. How about 3 and 5? It's 2. 5 and 7, 2. 7 and 9, 2. And this difference is called the common difference. And always, most of the time, represented by 2. In our case, common difference is 2. And the problem they ask, like find the 5th term of this sequence or 7th term of a sequence, we're going to write a general rule. Let's say nth term. So nth term of an arithmetic sequence with n terms. So this sequence has n terms and we're trying to find nth term. Can be anything like first, second, third, fourth, I don't know. With n terms and d as a common difference, d as a common difference, and a1 is the first term in the sequence. So you need to know the first term, then you can find the nth term. So the rule or the formula for nth term is going to be first term plus n minus 1 times common difference. And we can use it and see if that works or not. Let's say we are trying to find the third term in this given sequence. Third term. What is the first term here? A1. First term is 1 plus n is 3 because third term 3 minus 1 and common difference is 2, so multiply by 2. So a3 third term is going to be 1 plus 3 minus 1 is 2 times 2. So 1 plus 4, so 1 plus 5, 1 plus 4 is 5. So third term is 5. See, first term is 1, second term is 3 and third term is 5. That means this formula works. So you can remember this formula. So there is like explicit or recursive rules too. That's like next level. We're gonna make video on that later. The motive of this video is just to review the concepts or basic concept you need to know before you even start preparing SAT or ACT. Okay, let's write the rule for geometric sequence. Geometric sequence, and you will see the difference between arithmetic and geometric just right now. So each term is found by multiplying the previous term by a common ratio. Okay, so in geometric sequence, each term is found by multiplying the previous term by a common ratio, and we represent it by r. So let's do it. So I got 2, 4, 8, 16, 32, let's say, and so on. So this is a sequence. Is the common difference here the same? 2 minus 4 is 2, 4 minus 8 is 4. No, so that means this is not arithmetic sequence. Let's find a common ratio here. Get rid of this. So 4 divided by 2 gives me 2. How about 8 divided by this 4? Gives me 2. 16 divided by this previous term is 2. So you see the common ratio here is 2, represented by r. Okay, so each term is found by multiplying the previous term by a common ratio, and try it. So previous term was 2. If I multiply by 2, gives me the next term, which is 4. Now multiply 4 by the common ratio 2. 4 times 2 is 8. So 8 times 2 is 16. 16 times 2 is 32. So this gives us the next term. That means this sequence is a geometric sequence. Okay, and the nth term in geometric sequence is an is equal to a1. A1 is the first term, and r, which is a common ratio, raised to power n minus 1. So that's the formula we can use. Okay, let's try. How about find fourth term, a4. So first term here is 2. Common ratio is also 2. That's what we did. And n is 4 minus 1. So this is going to be 2 times 2 raised to power 3, which is 2 into 2 raised to power 3 is 8, and 2 times 8 is 16. So this tells us fourth term is 16. Let's see. First term is 2, second is 4, third is 8, and fourth is 16. So that is correct. So that's what you can use to find the terms in geometric sequence. Next topic is order of operations. Very important. If you don't understand this, you're gonna make a lot of mistakes while solving problems. So please practice to understand order of operations. So we use this. We call it PEMDAS, PEMDAS, stands for parenthesis, exponent, multiplication, division, addition, and subtraction. So what we do when they give you expression, and we're gonna use with the different operations, so we're gonna follow a order, we're gonna follow a rule. So first thing is evaluate any operation in parenthesis or brackets. That's P. And second step is evaluate exponents. See, second thing is exponent. Third thing is evaluate multiplication or division in order from left to right. Multiplication or division. If both operations are in the equation, so evaluate which one comes first from left to right. Even it's a multiplication here, If a division comes first and then multiplication, then we're going to use division first, then multiplication. So always from left to the right. And the fourth thing is addition and subtraction. So evaluate addition and subtraction at the end in order from, again, left to right, whichever comes first from left to right. Okay. So one of the example I'm going to use here is 7 plus 8 divided by 2 multiplied by 5. Okay. So do we see any parentheses? No. Any exponent? No. How about multiplication and division? Multiplication and division, yes. And what we're gonna do? Multiplication first or division? Even though here it says m first, but we're gonna go from left to right. Which one comes first? If you're going from left to right, division comes first. Okay, so we're gonna do the division first. So 8 divided by 2 gives me 4 multiplied by 5. So division first, and now we're gonna do the multiplication, 20. And now we're gonna do the addition. So 27 is the answer. One more example that will involve parentheses and exponents. So let me go, I got a bracket, 4 times 5 plus 6 divided by 4 square minus 12. Okay, so first of all, parentheses. Okay, so can we solve parentheses here? But we need to solve exponent. But here, yes. So 4 times 5 times 6 is 11. Okay, 4 square minus 12. And we got brackets. So 44 divided by, now solve the exponent. 4 raised to power 2 is 16 minus 12. So before we solve the division, we need to solve parentheses here. Okay, 16 minus 12 is 4. And now we're going to use the division. Okay, so 44 divided by 4 is going to be 11. So why we didn't do the division? Because before we do the division, we have parentheses here. So we need to solve this parentheses first before we do the division. So that's how you're going to use the order of operation. Okay. So let's go over a few other laws. So one of them is commutative law. Okay. So commutative law. So it says when adding or multiplying, order does not matter. So let's say I got 2 plus 3 plus 4. It can also be added as 4 plus 2 plus 3. And when we are multiplying 2 times 3 times 4, order doesn't matter. So 3 times 4 times 2 still give me the same answer. So when adding or multiplying, order does not matter here. Second one is associative. So when adding or multiplying, grouping does not matter. So this is about the grouping. For example, let's say 2 plus, and we group 3 plus 4 here. This will still give me the same answer if I group 3 plus 2 here and add 4. Same thing with the multiplication. I group 2 and 3, then multiply by 4, or I group 3 by 4, multiply by 2. So when adding or multiplying, grouping does not matter, still gives me the same answer. Third one comes distributive law. So it says when a grouped sum or a difference is being multiplied or divided, you may distribute the multiplication or the division. For example, I got 2 multiplied by a group 3 plus 4. See, so we group a sum and being multiplied by 2. Then we're going to distribute this 2 over these sums. So 2 will be distributed to 3 first, so 2 times 3 is 6. Then 2 we're going to distribute to 4. So 2 times 4 is 8. Okay, let me rewrite it again. Hold on. Okay, so 2 times 3 plus 2 times 4, this one. So this gives me 6 plus 8, answer is 14. Or let's say I'm grouping is in difference and we are multiplying it with the number, so same thing. 2 times 4, we're distributing 2, then minus, see, keep the sign here, 2 multiplied by 3, 8 minus 6, going to be 2. And remember, if there is a negative sign here, then you're going to distribute the negative sign too. So negative 2 multiplied by negative 4 makes this one negative 2, and negative 2 multiplied by negative 3 makes it positive here. Then the answer is going to be negative 8 plus 6, which is negative 2. So that is distributive law. How about in division? Let's say I got 1/2 3 plus 4. So same thing. Distributed 1/2 times 3 plus 1/2 times 4. Or let's say it is 3 plus 4 over 2. So distributed separately, 3 over 2 plus 4 over 2. So it says when a grouped sum or difference is being multiplied or divided, like here we are dividing by 2 and here we are multiplying it by 2, then you may distribute the multiplication or the division. Alright, so that was the distributive law. So these are the few concepts, they ask problems on, SAT or ACT test. So these are few concepts you must know before you start preparing for like more complex or more critical questions. So the goal of this video is just to, you brush up your basic skills. I'm gonna make the video on the main course too, but this is just for pre-SAT, students in 6th grade, 7th grade, 8th grade, even high school students can watch this video to review their concepts. So there will be second part coming to this video too. That's where I'm gonna go over more of algebra, geometry, like those kind of concepts. This is more of arithmetic, okay, concepts. So please share and subscribe to the channel so you won't miss the next video. And thanks for watching the video, guys. I really appreciate. Thank you. And please practice more examples. That'll help you a lot. Thank you. Have a good day. Bye bye.